From packhorse bridges to megastructures, bridges have been as vital to the progress of man as language. Without them, commerce and the spread of ideas could not have flourished. We have a wonderful selection in the northeast, all with at least one end in our county, and each with its story and its own mood on the day. This is a bowstring bridge, a method of avoiding the need for massive structural buttresses to resist the horizontal forces at each end of an arched bridge. We'd better deal with bowstrings now, as we'll meet them again and again later. When you load an arch, the ends spread unless restrained. To restrain them, you need heavy buttresses. Or, with the coming of wrought iron, tie the ends together with a bowstring. The arch now needs no external horizontal forces for equilibrium. To retain free navigation of the river, the road deck had an 85-foot clearance above high water, resulting in approaches which soar over riverside properties. Another bowstring bridge, with each span consisting of a cast iron arch kept in compression by wrought iron strings at road level. The bridge carries a road and pedestrian path on the lower level and a railroad on the higher. Construction started in 1847 and unfortunately coincided with the collapse of an earlier Stevenson bridge over the Dee near Chester, with 5 fatalities. The high-level bridge was a masterpiece. Dan Cruikshank, always a bit flowery, thought the bridge to be a pure and honest, almost abstract, sculptural form. The last of our giants. The requirement to build a bridge with a clearance of 120 feet above the river on a flat stretch of estuary land only a few feet above water level was more than a challenge. In its heyday, it opened several times an hour, to the delight of the maritime community and the frustration of the motorist. It could be raised in 1.5 minutes by 2 325 horsepower motors mounted at mid-span. Massive counterweights were linked to the deck to reduce the load on the motors as they lifted the 2,700 tons of bridge structure. Last lifted in 1990, it now continues to carry the A1032, but is permanently locked down. Taking just 3, we visit first the Fromelgate Bridge, built in 1400 to replace the original bridge, built for Bishop Ranulph Flambard in 1200. Until 1969, it carried the main east-west link across the Wear at this hub of the County Durham road network. A masonry arch bridge, it was built with 5 reinforcing ribs, later increased in the early 19th century to 7, when it was widened on the upstream side. Now mainly a pedestrian bridge, it enjoys a picture postcard location in the centre of this historic medieval town. Built in the 14th century and restored in 1781, the Croft Bridge may have been wide enough for medieval horse and cart traffic, but as the Industrial Revolution gathered pace, it was widened on the upstream side by 5 metres in 1795. The new construction was of harder grey ashlar sandstone as opposed to the original red sandstone. At Toll Bridge until 1879, it hosts the welcome of each new Bishop of Durham into the diocese. The bishop is traditionally presented with the Conyers falchion, the sword said to have been used by Sir John Conyers to slay the Sockburn worm in 1063. The Newton Cap Bridge at Bishop Auckland was built by, or at least for, Bishop Skirlaw, in, again, about 1400. Now only used as a diversion when high wind closes the nearby ex-railway viaduct, it was once the river crossing for the main north-south Deer Street, bequeathed to the nation by the Romans. The Roman fort of Vinovium lies close by at Binchester, and Auckland Castle, the historic home of the Bishops of Durham, is even nearer. It's hard to believe that this quiet backwater was once a critical link in the national road network. A long way from the mighty Humber Suspension Bridge, the first road bridge to adopt the principle was built to carry the Staindrop to Greater Bridge Turnpike across the Tees at Walton. Built in 1831 using wrought iron chains made at the Gospel Ironworks in Staffordshire, it was a toll bridge until 1914. The crossing was originally intended to be a traditional masonry arch bridge, but the early stonework was swept away by the notorious Tees bore. This was the age of engineering innovation, and the radical suspension design was seen as a way of keeping the structural elements of the bridge well out of harm's way. Among the most quirky must be the Swin Bridge on Cockfield Fell. The Swin Bridge is a skew bridge, and the design of skew bridges exercised the best engineering brains in the early 1800s. Skew bridges were a means of shortening the span of bridges crossing an obstacle at an angle. Straightforward arched bridges with a keystone were easy to design, but as soon as the abutments start to move out of line, lateral forces are generated and instability increasingly threatens. The necessarily complex geometry of the stonework was solved in many and imaginative ways. Fast forward 130 years and we arrive at the Kingsgate pedestrian bridge over the Wear, in the shadow of Durham Cathedral. Personally designed by Sir Ove Arup and winner of many architectural awards, it is a subject of much academic appreciation. Not my cup of tea. It links the brutalist Dunelm House, the Students' Union building, to the Cathedral Peninsula. I don't think much of the bridge, but Dunelm House would look more at home in the Maginot Line or Hitler's Atlantic Wall than in this otherwise regal landscape. From an engineering point of view, the method of construction may be well appreciated. The structure was built in two halves, each parallel to the river. They were then rotated about the base of the supporting columns to meet at mid-span. The Infinity Bridge carries pedestrians and cyclists and links the Teesdale Business Park on the north bank of the Tees at Stockton to the Durham University campus on the south bank. In keeping with its academic roots, it forms a lemniscate curve, the mathematical symbol for infinity, when its illuminated arch reflects in the water of the river at night. The bridge design was selected from 200 competition entries and has won many prestigious prizes, including the Institution of Structural Engineers Award for Structural Excellence in 2009. Another bowstring design with 4 bowstrings per arch, it also incorporates 7 tuned dampers to control both vertical and horizontal oscillations. The offset pier support is positioned to minimize interference to pleasure craft and water sports activities. We are lucky to live in this beautiful county, reminded at every turn of the genius of our forebears.